So, what we're going to have a look at is just talk a little bit about what you need to do in the coursework. Did you finish your lab book?
Yeah.
Yeah. Oh no, I'll get it off you later when the other people are here. I feel like we should have class in the canteen, you know, it's only two of us. Relax, have some coffee. Oh well. Did you finish the lab book? Was okay? Yeah.
Just the velocity. I could graph the 3.0.
Yeah, someone else did as well. I'll have to look at it later. Or do you want me to look at it now? Do you have it?
Yeah.
I'll have a look at it now. Well, no, I'll look after this.
Let's do
Yeah.
this, yeah.
Ah, that must be EAD.
Yeah.
You are downstairs.
E302.
302.
Hey.
I don't think that'll be the last. Okay, what was I saying? Oh yeah. We'll talk about what you need to do for the coursework.
The calculation you teach us in the last lab report, is it all the calculation that we need?
Yeah. Well, I mean, you also have to calculate the A from the U and the V, you know.
Yeah, but I talk about the Excel.
The what?
Excel.
Oh, the Excel calculations is all you need, is that, yeah. Yeah. So, firstly, yeah?
But yes, I want to write what you
Okay, well, I'll tell you, you don't need to write this. This here, I have to tell you what the marks are. So that's the first thing, is I have to tell you what you're about to hear. So that's the first thing. Okay, so you must use Word. Of course you're using Word, like Microsoft Word. And the word count is 1,000 to 1,500. Now, if you want a good grade, it's going to be, needs to be nearer to this than to this. Like, this is to pass, this is to do A, you know, yeah, yeah. And then also calculations and diagrams and references, not included in this. So in the report you should have first section, introduction and theory, firstly. The procedure, you know, the equipment, the diagram and all this. The results, the analysis, discussion and conclusion. And these are the 5 main sections. Now in the analysis, that's kind of like the Excel part that we did.
What is the result then?
Remember, you're trying to get the mass from the slope,
Yeah.
plus the uncertainty, and compare that with the true mass. It should be nearly the same. You know what I mean?
But what is the real mass?
You can remember, you measure it with the spring
600, I mean.
plus the weights.
But the weights are changing every time.
Remember, you only move the weights from the car to the pulley.
Yeah.
It's the same all the time. This is the reason why you put the weights you don't use on the car, to keep it the same, you know. Okay, so do you want to write these 5 sections down? Yeah.
This year you mean Newton's second law, yeah?
Yeah.
So we talk about if you want to reference from a book.
Yeah. It's easier to reference from a book.
But everyone knows what is Newton's second
I know, I
Do you
know.
have to difference it?
Well, it just, to be honest, in your marks, you get marks for a reference. And really, I don't care if you reference Newton's laws from a book. I just need to see a reference so I can give you the reference mark. You know what I mean? Yeah?
Yeah. So the analysis is the part will I use Excel on it?
Excel, the graph,
All Excel.
yeah, all Excel. But you need to include the Excel calculations in the analysis. You know the way I made the table with the X, the Y, residual X, residual Y, and then the averages and the uncertainties. I need this table.
In the analysis.
Yes. Yeah.
So what is the result then?
The result is the slope with the uncertainty of the slope. Sorry, the mass with the uncertainty of the mass.
Just this.
Well, I mean, you have a lot to do to get to this. Yeah. Oh yeah, no, sorry, Ms. Sharif, the difference here, this results, this here, that's like the data. And the analysis is the calculations on the data.
So in the result I have to say what is my U and V and A and S and weight.
Yeah, and the units and have the table with the data in it.
And then after that, in the result, I have to calculate the mass with the uncertainty.
In the analysis.
You said in the result?
I misspoke, I'm sorry. In the analysis is where the calculations go.
So the result is only the data?
Yes, yeah.
Okay.
Yeah. This is Musharif's physics lab class.
So in the analysis, if I get the weight, it's not the actual weight.
You mean mass?
The mass.
Yeah. That's fine. But if it's not, you need to talk about it.
Yeah.
So it's much easier if it is the same, you know? It's a pain if it's not. But you don't know until you calculate if it's the same or not.
So if it's not the same, I have to talk about why it's not the same.
Or maybe we could
Change?
maybe.
Okay.
We'll see what you get. We'll see what you get.
So where can I say how did I minimize the error?
Yeah, talking about minimizing the error. Firstly, in the procedure, you could talk about what to do to minimize the error. Like, make sure the table is level, you know this word?
Yeah.
But also, in the discussion conclusion at the end, you must talk about what else you could do in the future to minimize the error. You know what I mean? Like if you could do it again. But we'll look at more detail in each section now. Yeah. So.
Can you explain to me what is the discussion and conclusion?
I think there might be slides on each of these we can look at when we get to. So like the first thing I want to talk about is the introduction and theory. That's 10% of the mark. So you need to list all the equipment, obviously. Next, you need to make sure you clearly explain how to measure with the equipment, how to use the equipment.
I think this is more for the procedure to list all the equipment, not for the instruction.
Yeah, sorry, yeah, well, I think I call it, oh sorry, you're right, that's the procedure. Well, introduction and theory is just notes from books, and this is the procedure, the plan. Justify choice of equipment. What's wrong?
Use all the equipment. Justify?
Yeah, you know this word? Explain why you use this equipment, yeah. The next one is you need to show the importance of repeated readings, repeating the experiment, different values.
Why it's important?
Yeah.
Why?
Why? Because the more readings you have, the more accurate your slope can be. Because, for example, if you have 100 points, you can get a very clear line, but if you only have 3 points, it's not so clear. Now, you were talking about the minimizing the error. You also need to talk about that. Importantly, how to control it. So, for example, make the table level, make the table smooth, stuff like this. Yeah. State which is the independent and which is the dependent. In other words, which is the x and which is the y. Yeah. Draw a diagram.
So the theory is end now for the procedure. The theory is end now.
In this one?
Yeah.
This, I need a diagram with the equipment, like how to set up the experiment in the procedure. And then also you need to talk about the safety aspects. You need to also talk about how the data will be used. So for example, you need to say like the U and the V will be used to calculate the A. The mass hanging will be used to calculate the force. Do you understand? Yeah. Next, what is the main cause of uncertainty or error? And lastly,
What is the main or is made on my experiment?
I think the main cause of error will be something from the table, like the table's not level or smooth. It really depends. And lastly for this, make sure it's organized, of course, not to be messy.
I have a question.
Yeah.
In the procedure, do I have to say like we put the trolley and then we measure it and
try not to use pronouns.
Yeah, I know, but is it in how do you use them in number C, I think?
Yeah. It's hard to explain, but
I mean, I can say how did I
you see,
get this data.
yeah.
Like I put the photo get and I put a blue tag under it and I put in the past classifier.
Yeah. Sometimes students like to make subsections. So you could have one section which is the procedure, and then one section which is like an explanation of, for example, why you chose your equipment and what could be the error and what's the safety. You know, you could separate it into like the instructions and then some extra information like about safety and choice of equipment. Like that's just my idea. If you want to separate it into two, you know. You see, they don't really care too much. They just care that it's well organized. So if you want to do like two subsections, the procedure and a discussion of the procedure, that's fine. If you want to try and put them together into one, that's fine. Just once it's organized, easy to read, it's okay.
In chemistry,
Yes.
we wrote how did we do the experiment. This was
Like how? Give me an example.
like first we fed the equipment was watched by the ionized water to make sure that it's not have ions, because the normal water have ions with the acid. And then
Physics one isn't really like that. It's a bit more, this is what you do, this is what you need to be careful about, do the experiment, collect the data, and then talk about any problems at the end. It's more like this. Okay. So, in the introduction and theory, at the start, of course you need the title and the aim. And of course the theory should have references. And that's the main two things I needed. Now, of course, the theory, what could you talk about? So you can talk about Newton's second law, you could talk about Newton's three laws, you could talk about the formulas, UVATS, you could talk about, well, you can talk about a lot because it's Newton's three laws, you know. You can talk about gravity. There's so much you can talk about, but try to focus on Newton's second law.
Can I talk about all of them? Music and UV,
That's fine, but make sure the most important and most discussed part is Newton's second law. Yeah. And make sure you have references. Yeah. Okay.
All of them?
No, just like, for example, if you talk about Newton's three laws, you can copy them from a book because they're like a law, so they can be, you know, quoted, but you should reference it.
With using what?
What do you mean?
How do you reference them?
I use Zotero. Zotero, and you put the ISBN number in, and it's easiest. Okay. Next, yes? Right, so what are your marks for the procedure? So for the procedure, I need to see the equipment correctly assembled and tested. So make sure in your procedure you talk about ways to test the equipment to make sure it's working. Now, for example, with the spring balance, what do you make sure at the start before you use it?
The spring?
Yeah.
It's in the...
Yeah, but how do you check that it's okay before you use it? You need to make sure that's zero. The reading is at zero before you use it. Do you know what I mean?
The reason of what?
The spring, the weight.
Yeah.
It needs to say zero before there's a weight on it. Do you understand? What could you do to test the light gates? Well, you need to make sure they're at 0 as well. You know the word calibrate? Calibrate means to check it's at 0. Yeah. Anyways, the equipment should be operated effectively. So you need to show in the report that you use the equipment correctly. I can kind of see that if the U and the V are right, you know what I mean? For example, your V should be bigger than your U, obviously. The diagram should be labelled and clear. The procedure should be clear, and now this is important, in the student's own words, so not a procedure from the internet. And that's the main things for the procedure. Now, for the results, okay, you need to have the observation, this means the data, with uncertainty values. So, for example, when you list, for example, the U, you need to put beside the U the uncertainty. So, for example, 0.01 or 0.005 if you want to use half of it. Yeah. You should have the correct units, of course. Correct units, you know.
So U and V, I can get it. And S is 0.01 centimeter. 0.01 centimeter.
Yeah, 0. No, that's too small. I think more like
0.2 or
0.2, maybe, yeah. And there's not the uncertainty for the weights. What's the uncertainty for the weight? So, like the 50 gram weight, what's the uncertainty? I would say it's half a gram. Now, why do you think I'm saying half a gram? Because the weights are measured in grams. Like, it's not 50.1, it's 50, 100. They don't use decimal places, so the smallest value is 1 gram, so it's half a gram, half the smallest value. Okay. Measurements should be taken over an appropriate range, which you did. What did you go from 50 to 400, 450? 500, yeah. And then the main things for the results. Okay, next, the analysis. So make sure you have a straight line. I showed you how to do that yesterday. Don't forget about the title and the X and the Y. I talked about that yesterday. Points should be plotted accurately. The program will do that for you. The only reason it won't is if you typed it in wrong, the wrong number. Yeah. The line should be drawn. I showed you how to do that. The slope should be calculated. I showed you how to do that using the slope function. The intercept should be calculated as well. I showed you how to do that. The data should be displayed appropriately. That means in a clear table, easy to read. Do you understand?
What?
Data should be displayed appropriately. That means the data should be easy to read in a table in your report. Do you know?
So I have to make a table for the results and also for the
yeah. Discuss relevant physics principles. So what would be the physics you would discuss in the analysis section? Well, the data only has U and V, correct? But do you use U and V in the analysis? No, what do you use? The A. So you need to discuss how to get the A from the U and the V. Do you understand?
No.
Right. No, don't type. Listen, and then you can type, okay? In the data, you have U and V, no A. In the analysis, you need A. You don't want U and V. So you need to discuss how to get the A from the U and the V. How do you do that? From the formula. Exactly. So this is what I mean by discuss the relevant physics. Do you understand that?
Yeah, but I have to discuss this.
Oh, you can say like, no, don't type. Listen, so you understand, then you can type. You can say something like, from the U, the V and the S, we can calculate the A by using the following formula: V squared equals U squared plus 2AS. In the table above, there is a column with A that has been calculated from U and V from the table in the results section. You know, something like this. Now this is being recorded, so you can listen to this again later. Yeah. Okay. Now you need to check for accuracy. So a couple of ways you can check for accuracy. What should happen when the weight increases?
U and V increase.
Or, well, more accurately, the A increases. What else should increase? What else should happen? So bigger W means bigger A. Also, the V should be bigger than the U. You know, you need to do some things to check that everything is working okay. What else could you do to check for accuracy?
But I don't have to write this.
Oh no, you do, because this is where you're getting the marks. So like, for example,
I have to say, like, all the U are less than the V and
the A is increased with the W. Yeah, because you need some way to make sure everything is going okay. Because, for example, I can't remember who, but one of the students, their V's increased, and then they started to decrease, and then increase again. So this means something went wrong, you know.
is there anything gets bigger also? U, V, A. The weight is constant.
Well, the weight's getting bigger. The hanging weight, the force. No.
No. Yeah.
No. Okay.
You said the force is the same because you changed only the.
No, the mass is the same. The force is increasing because there's more weights hanging weights. Yeah. I showed you yesterday how to calculate the uncertainty.
Yeah.
Yes. Okay, now time for the discussion. Valid conclusion. Oh.
Uncertainty calculated valid.
In other words, calculate the uncertainty correctly. I showed you how to calculate it yesterday. Yeah. Okay. Continue? Yeah. Valid conclusion should be clearly stated. So the conclusion here is what?
You can get the mass from the flow of force and
Acceleration. By using Newton's second law.
sorry.
Is that Iad?
No.
Oh. By using Newton's second law. Therefore, we can verify Newton's second law, you know. Also, the true mass doesn't have to be exactly what you got. It just needs to be within the uncertainty values. You know what I mean? It's important that you suggest how to improve the experiment for the next person who does it. And these are the two key things for the discussion. Two key things. Now, 10 marks for style. You should have sections and subsections.
In the introduction, I don't have subsection because it's only 4 lines.
You can have subsections. It depends how much you write. Try not to have grammar or spelling mistakes. Academic style, past passive. References, using Harvard. Yeah, the usual stuff. Now, for high marks,
No, section and subject.
what's that?
Section and subject. Section.
Yeah, yeah. For high marks,
How do you do this?
oh no, but that's up to you. It depends what you're writing. So, for example, just an example, like if I was writing something about the theory, maybe I have subsection Newton's first law, subsection second, subsection third. For an example, you know. Okay, for high marks, there's nothing really too interesting here, Musharif. It's just, it has to be excellent justification, excellent evidence of knowledge of technique, excellent diagram, excellent consideration of possible errors. You know, you consider all the errors, you consider the safety. Basically, everything here has to be excellent. So, excellent title and aim. Now, look here. Look. Theory is introduced with 3 or more references for the theory. So you need at least 3. Excellent discussion, valid conclusions. Excellent suggestions made to improve the experiment. Excellent, yeah?
Excellent discussion.
Yep. Make the discussion excellent. So, like, for example, the conclusions need to be valid, the right conclusions. More difficult is excellent suggestions to improve the experiment. So you need to think of maybe 2 or 3 ways you could do the experiment better next time, you know. Excellent structure. So you know things like section, subsection, tables need to be clear, titles, you know, like everything needs to be easy to read. No grammar errors, no spelling errors. A good academic style. References are listed in Harvard. Clear evidence the equipment was correctly used.
But if I got the math right.
Yeah, so like if the data is correct, it should, that's like proves that you did it right, you know.
So I don't have to do anything for number E. If my calculation is right, then number is excellent.
Yeah. That's what I mean. If something is wrong, you kind of have to explain why. Excellent diagram, of course. Excellent description in students' own words. Excellent results, meaning
The answer.
with the uncertainty, with the units, you know. Realistic uncertainty. For example, if you said 0.01 for the length, I would say that's not realistic. That's too small. Probably more like 0.1 centimeters, 0.2 centimeters maybe. That's fine. Now the Excel part should be perfect because Excel is making it. Yeah. So just don't forget like units, label, title, you know, things like this. And don't forget to discuss the physics, like for example, how to calculate the A from the U and the V. You know. Excellent graph, so no mistakes making the graph. With the title and the x-axis, the x and the y. The gradient is correct, all that stuff. Calculations are correct. Uncertainties are correct. Conclusion is correct. I think there might have been something cut off here. Let me just check. Because I feel like there's more underneath. I might be wrong. I'll just check for you. Come on. Wakey. Oh, here we go. Oh no, that's the end. Yeah, conclusions are clearly stated. Yeah.
What?
Least squared fit is the name of the function that Excel uses to calculate the slope. So, for example, this method, least squared fit, basically means Excel. This method, large triangle, is what you did in your lab book, where you take 2 points and calculate it from a triangle.
What?
In your lab book,
Yeah.
when you got the slope, you took 2 points, and what formula did you use? y2 minus 1. Yeah, that's like making a triangle. So, when they say using a large triangle, that means using the formula in the lab book. Least squared means using Excel. Now, why do you think I tell students to use Excel and not this method? Because you have a choice. Why do you think I tell students to do this and not this?
More accurate.
In other words, you should get full marks for this method. But as you can see, when you did the gravity experiment, did you get the right value of G? No. So that's why I don't talk about this, because you have a choice, this or this. So forget about that. Do it using Excel. Yeah? Okay. Anything else? Now, we have class later today. Don't we?
Yeah.
At what time? Is that 4 o'clock?